Hi class, this is Mrs. Lyons. Today's video talks about how to translate word equations into chemical equations. Okay, so sometimes you'll be given instructions in words and the chemical names, and you need to write that as a chemical equation. So let's take a look at 3 examples. The first example is you have chlorine gas, and this chlorine gas reacts with solid calcium to form solid calcium chloride. So we need to think about some key words that we're going to look for in our word equations. Reacts with is always going to be assigned to us. If something reacts with something else, that's going to be where our plus sign is. So in this case, we've got chlorine gas. We know that chlorine is Cl. Now we got to think about something. Here's where this whole Haber-Finkel comes into play. Haber-Finkel, chlorine is one of the Haber-Finkel compounds. What does that mean? That means when we write it in an equation, we have to write it as the diatomic element. So Cl2, don't miss the fact that it tells us it's a gas, so we just do parentheses G. Alright, it's going to react with solid calcium. So we're going to write down calcium. Calcium isn't one of our Haber-Finkel elements, so we're just going to write down calcium solid. To form. Here's another key word phrase. To form means to produce or yield. That's the sign that we need an arrow here. So we're going from reactants, now we're into products. And our product in this case is solid calcium chloride. So it's a compound calcium chloride. Now before I put it up in here, my equation, I want to think about what is calcium chloride. We know it's calcium. We know it's CaCl. But we can't just write CaCl. We have to think back to our last unit. Calcium chloride is an ionic compound. So we've got to look at the charges and we've got to crisscross them. If you look at your periodic table, calcium is in group 2, so it would form a +2 ion. Chlorine is in group 17, so it would form a -1 ion. If you crisscross these, calcium chloride is going to be CaCl2. So our product over here is going to be CaCl2, and don't forget, it tells us it is in a solid state. Now, just for the heck of it, let's check this and see. And this one, look at this. This is really nice. We've got 2 chlorines in our reactants, 2 chlorines in our products, a calcium and 1 calcium. So this equation, as it's written, is already balanced. It's like a little Christmas present. We don't have to balance it. But you should always check to see if you need to balance. Okay, so moving on to a second example. Hydrogen peroxide decomposes to form liquid water and oxygen gas. And I should have told you that this is liquid hydrogen peroxide. Okay, now I don't expect you to know what hydrogen peroxide is. It's beyond what we've learned, but notice I give you a formula here. So we can start out with H2O2, and I told you it's a liquid. All right, and we said that this decomposes to form. Okay, now even though we really haven't talked about decomposition reaction, we see the words to form in here. So something's happening, it's decomposing, which you should know that means it's kind of falling apart. But to form is the sign that we need our arrow. And then we're going to get to our products. Liquid water. You should know what water is, right? H2O. We're going to put liquid. And oxygen gas. So we've got oxygen. Remember, oxygen is one of our Haber-Finkel elements, so O2 gas. Now, this one, unlike the first one, let's see, is it balanced? We've got 2 hydrogen here, 2 hydrogen here, 2 oxygen, 2 oxygen. Oh, but there's that pesky third oxygen. So let's see if I can think about, I'm gonna just balance this by inspection is what it's called. I'm going to see if I can just kind of plug in some numbers and get this to balance. So right now I have 4 oxygen. If I put a 2 over here, that gives me 4 oxygen, 4 hydrogen, so I have a balanced chemical equation. Let's do one more practice. Alright, so this reaction says we have aluminum metal reacts with aqueous silver nitrate to produce silver metal and aqueous aluminum nitrate. That's a mouthful. Aluminum metal. Okay, so we're just talking about aluminum, so Al. What state would that be in? Now this asks you to think about things. Aluminum metal. What state is a metal in at room temperature? We know that that's solid. Reacts with, so that's going to be plus, it's reacting with aqueous silver nitrate. Okay, so we got to think about this silver nitrate. We know that silver, remember silver is one of those I told you have to remember it's +1. Nitrate, if you look at your polyatomic ion chart, NO3 -1. If we crisscross those, we get AgNO3. And it tells us that it's aqueous, so AQ. Let's see, to produce, that's our yield sign. Silver metal, so we've got Ag as a solid, and aqueous aluminum nitrate. So we've got aluminum, if we look, aluminum's in group 13, so that's +3. Nitrate is NO3 -1. If we crisscross those, we get AlNO3 3. Don't forget, it's aqueous. Let's see if I can fix that. Aqueous. Okay, now, is this thing balanced? Not quite, because I've got 3 nitrates over here, so I would have to put a 3 here and a 3 here, and now it's balanced. Okay, so word equations to chemical equations, not very bad as long as you remember your states, and remember if it's an ionic compound, you have to crisscross your charges to make sure your subscripts are correct. Okay, so that's a quick look at how to write word equations into chemical equations. I'll see you soon.